This conference will now be recorded.
So the question, what is the answer for 7th question? Prepare 0.5 normal 1000 ml sodium hydroxide. How much you got?
20 grams.
20 grams. Next, 0.2 normal.
4 grams. 4 grams.
0.2 normal 500 ml 4 grams. 0.05 normal 100 ml
0.2 ma'am. 0.2 grams ma'am.
0.2
Gram.
Everyone got?
Yes
ma'am.
ma'am.
Next, 2 normal 750 ml
60
grams.
grams. 60 grams ma'am. 60 grams.
Next, 0.01 normal 400 ml
0.16 grams.
0.16 grams. 0.16 grams.
Okay. So shall I do this sum? 0.01 normal. For example, yesterday few people asked sodium hydroxide. Zero point zero one 400 ml. So 80 grams of, not 80 grams, it is 40 grams, right? The standard molecular weight of sodium hydroxide is 40 grams. So, and equivalent weight of sodium hydroxide is 40 grams, because equivalent weight means molecular weight divided by number of replaceable hydrogen or hydroxyl ion. Sodium hydroxide has one replaceable hydroxide ion. So 40 divided by 1 is 40. So molecular weight and equivalent weight will be same. So 40 grams of sodium hydroxide in 1000 ml will be 1 normal or 1 molar. Both are same. 40 grams in 1000 ml, 1 normal. So you need to find out for 0.01 normal. So x is equal to 40 into 0.01 divided by 1. So how much it will be?
0.4. 0.4 grams.
0.4 grams. So 0.4 grams in 1000 ml is 0.01 normal. Now how much you want? 400 ml. So how much? X is equal to 0.4
into 400 divided by 1000 into 400
into 400
divided by 1000.
divided by 1000. So what will be the value?
0.16 grams. 0.16.
0.4 0.16 gram. So you need to take 0.16 grams of sodium hydroxide in 400 ml water to get 0.01 normal sodium hydroxide solution. So similarly, you can calculate for others. So next is oxalic acid. So oxalic acid, what is the molecular weight of oxalic acid?
126.
COOH. So this is the oxalic acid. So how will you calculate? We have carbon. What is the molecular weight of carbon? What is the molecular
12,
weight of
ma'am.
carbon? 12.
12.
So how many we have?
2.
2. So it will be
4.
24.
24.
Oxygen?
1.
16.
1 into 2.
16. How
Into
many we
4.
have?
Correct.
4. So it will be
64.
64
64.
plus hydrogen.
2 into
1.
into 1.
2 into 1. 1 into 2.
1 into
2.
2. 2. So this is oxalic acid, but whatever
90.
we are using in the lab is dihydrate. So it is
Dihydrate.
having two molecules of water. So what is water?
क्या हुआ?
H2O.
क्या?
H2O is oxygen 16 plus 2, 18.
अच्छा,
18.
तो क्या अभी करना है? पता नहीं जाम वाम हो रहा है कुछ, तो पूछते हैं अभी। 1 मिनट रुकिए।
So plus 18. So total how much it will be?
126, ma'am.
126. Gram. So molecular weight of
ड्रेन पाइप लीकेज के लिए आए हैं। ड्रेन पाइप
molecular weight of oxalic acid is 126 grams.
108, ma'am.
Not 8.
Yes, ma'am. Not 8.
How 108?
8 plus.
So it is 2 molecules. It will be plus 18.
Yeah, ma'am. There will be 36.
It is dihydrate, right? 2 molecules of water. 18 plus 18. Now is it 26? So molecular weight is 126. Now equivalent weight. What is the equivalent weight?
63 because of 2 repressible hydrogen.
So first tell me the formula of equivalent weight.
Molecular weight divided by repressible hydrogen.
M4.
Molecular weight divided by
Repressible hydrogen ion.
number of replaceable Molecular weight divided by number of replaceable hydrogen ions. Molecular weight is how much? 126. So 126 by 2
2.
is
63.
equal to 63 grams. So when you want to prepare molar solution, how much will you take? When you want to prepare molar solution, how much will you take?
126.
126 grams. But when you want
Yes,
to
ma'am.
take normal, for normal solution, you need to take 63 grams.
63 gram.
So now 63 grams of oxalic acid in 1000 ml.
That is 1 normal.
Okay. 1 normal. Now
X gram of
how much you need
oxalic
to
acid.
find out? So which one will they take?
0.5 normal.
So 12th one will we take 0.5 normal 1000 ml. So we need to prepare 0.5 normal. So now X is equal to 63 into
63
0.5.
0.5.
0.
So how much?
31.5.
1.5.
60 into 0.5 is 31.5. So 31.5 grams in 1000 ml will be 0.5 normal. How much you want now? 500 ml?
1000, ma'am.
1000
1000 only?
ml, ma'am.
0.5 normal,
Yes, ma'am.
1000. So 31.5 is your answer. That's it. You have to take 31.5 grams in 1000 ml water to get 0.5 normal oxalic acid. Next is 0.05. So 0.05 means how much?
0.63 grams. 0.63.
0.63. How 0.63?
3.15 miss. 3.15.
Yes, 3.15 grams. So 3.15 grams in 1000 ml will get 0.05.
05.
So how much you want to prepare?
200 ml.
200 ml. How much it will be?
0.63 grams.
3.15.
3.15 into 200
divided by
into
1000.
200
divided
divided by
by 1000.
1000.
0.63 grams.
0.63
grams.
0.63 grams. So 0.63 grams in 200 ml will get 0.05 normal. Sodium hydroxide and oxalic acid are solid substances. So for solid substances, no need to check for density. Density is checked only for solvents because liquids, because you need to take volume. You have to measure the volume. So when you do the calculation, it will be done in grams. So that gram should be converted into ml. That's why you are seeing the density of liquids. Whereas solids, so oxalic acid directly you can make 0.63 grams. So sodium hydroxide 40 grams. These are all solids. So clear? No doubts, no?
No, ma'am.
Ma'am,
Yes.
should the
Yeah, ma'am.
density will be provided in the question?
I didn't get. Repeat. Density?
Ma'am, should density will be provided in the question?
No. You have to know some standard values of some compounds, standard compounds. Sulfuric acid, hydrochloric acid, nitric acid. So all this you should know the density. It will not be given.
Ma'am, can you explain how to calculate it?
Which one?
Density of
Density is not calculated. It's a standard value for the given chemicals. You need to by heart. You have to keep in memory.
okay.
So if you take 1 ml, how much it is going to weigh? That is the density. You need to keep it in mind. Example, sulfuric acid density is 1.84 grams or 1.83. Sometimes they'll be giving in the range 1.82 to 1.86. So you can take the in between or any value from 1.82 to 1.86. So next we'll move on to standardization.
Ma'am,
Yes.
we calculate density in second PC, ma'am,
How?
by formula method.
Yes. Tell me. How will you calculate the density of sulfuric acid? Do you remember? Yes. How will you calculate? So better you just revise once and keep it in memory. We don't want that calculations and all here. Just we know we want that number. So today we'll discuss about what is standardization, what do you mean by primary standard, what do you mean by secondary standard. So what do you mean by standardization? Where does this term is used? Standardization. Where does this word used? In which reaction or which method we are using this standardization?
Volumetric method.
Yes, titration or volumetric analysis. We use the word titration. So what do you mean by standardization? Standardization means determination of strength of a given sample solution. So standardization is nothing but you are going to find out the strength of the given solution. So how is this strength measured? Strength is nothing but here strength means what here usually? Concentration. So concentration is expressed in terms of
molarity, normality.
yes, molarity and normality. So you're going to find out molar or normality of the solution. So that is nothing but standardization. Standardization means determination of strength of a given sample solution and can be used to determine by reacting the solution quantitatively with a standard solution. So that standard may be of two types, that is primary standard and secondary standard. So what do you mean by primary standard? So primary standard is a solution of known strength made from the substance of high purity. So primary standards are highly pure compounds, and these substances when you weigh and dissolve in definite volume, you will get the exact strength. So the normal and molar solutions will be very accurate in primary standard. And the substance which are termed as primary standard should satisfy the following conditions. Some conditions they need to satisfy. Like it should be highly stable. So that means it should have some good stability. Second, it should be obtained in pure state. So the compound should be obtained in the pure state. And it should have high molecular weight. The molecular of the substance should be very high. And it should be of high solubility. That means it should be readily soluble in water. Then only you can choose the substance as primary standard. So any primary standards you know till now? Any primary standard you know? Examples for any primary standard. Have you done standardization in your 12th standard?
Yes, ma'am.
So which standardization you have done?
Trichometric.
Which standardization have you carried out? For what substance you have carried out?
Ma'am, for KMNO4, oxalic
KMNO4.
acid.
Oxalic acid you have done standardization?
Yes, ma'am, but can't remember.
No, you are not doing standardization of oxalic acid because oxalic acid is a primary standard. So you need to standardize for secondary standards because secondary standards is a solution of known strength which is previously standardized by a primary standard. So they are not pure substances. They need to be standardized using the primary standard. So you have done standardization of sodium hydroxide using oxalic acid. So you have standardized sodium hydroxide solution using oxalic acid. So why we need to carry out standardization for secondary standard? Primary standard example is oxalic acid. Secondary standard example is sodium hydroxide. So why secondary standard should be standardized? Because secondary standards are not pure. They are to be standardized using primary standards. So any other examples for primary standards? Sodium carbonate. Sodium carbonate is a primary standardized, used to standardize acids like sulfuric acid and hydrochloric acid. You can also use. So anyone knows what is PHP?
Potassium hydrogen
Good. Hydrogen.
phosphate.
It's not phosphate. Phthalate.
Phthalate.
Potassium hydrogen phthalate. Potassium hydrogen iodate. Potassium hydrogen phthalate. Oxalic acid. Sodium carbonate. Potassium dichromate. So these are the examples of primary standard. Secondary standard example. Sodium hydroxide, hydrochloric acid, sulfuric acid. These are some of the secondary standards. So different reactions will use different primary and secondary standards. So oxalic acid is used to standardize sodium hydroxide. So this is an acid-base reaction. Similarly, hydrochloric acid and sulfuric acid are standardized using sodium carbonate. This is also an acid-base reaction. Potassium dichromate is used in standardization of redox reactions. Potassium hydrogen phthalate is again used for standardization of sodium hydroxide. Either oxalic acid or potassium hydrogen phthalate can be used to standardize the sodium hydroxide. So how will you prepare the solutions? Preparation of standard solutions. So will you prepare standard solution? So in which glassware you are going to prepare standard solution? This is the glassware used to prepare the standard solution. Yes. Which glassware will you use to prepare the standard solution?
Class 11, ma'am.
Name of the glassware. So can
Class
anyone
11.
name some glassware which you know, which you have used in the laboratory? Which glassware you know? If you want to prepare a solution.
Purettes.
Burette is used to prepare a solution.
Conical flask.
Test tube.
Is used to prepare solution.
Test tube.
Test tube.
Beakers.
Beakers. Okay, you are telling some glassware which you know. Okay. So in which glassware you are going to prepare the solution? If you want to prepare any solution, which glassware you are going to use?
Conical flask.
Conical flask.
Okay.
Conical flask, ma'am.
Flask. Everyone will use
Flask.
conical flask.
Yes, ma'am.
I am not asking for titration. I am asking if you want to prepare any solution.
Beaker.
Beaker.
Beaker, ma'am.
Yes, ma'am. Beaker, ma'am.
Okay.
Beaker
Now we
and
come
test
to
tubes.
test tubes. In test tubes, will you
Yes,
prepare
ma'am.
this solution?
No, ma'am.
Yes, ma'am. For the
Hmm.
ring test.
Hmm. That is solution preparation you call. It's for identification or doing some performing the test. We use test tubes.
Yes, ma'am.
Beakers we can use to prepare. So now when you come to titration or titrometric analysis, to prepare the standard solution, which is the glass base used. It's not beaker.
Burette.
No, burette is used only to store the solution during the titration. When you want to do the titration, at that time the prepared solution is poured into burette and you are doing the titration. It is not used for preparation. So what do you mean by preparation? You want to take solid or liquid, mix it with solvent to get the solution. So what is the glassware used? Nobody knows? So the glassware used to prepare standard solution is volumetric flask, or it is also termed as standard flask. Keep it in mind, we use only volumetric flask or standard flask for the preparation of standard solutions. So whichever the solutions you are going to prepare, either a primary standard or a secondary standard. So we need to prepare only with the help of volumetric flask. So we have volumetric flask, different size. So it's available from 5 ml. So you can prepare 5 ml to 5 liters. So we have 5 ml volumetric flask, 10 ml volumetric flask, 20 ml, 25 ml, 50 ml, 100 ml, 200 ml, 250 ml, 500 ml, 1 liter, 2.5 liters, 2 liters, 5 liters. So we have various sizes of volumetric flask. So depending on what quantity of solution you need to prepare, you can use the particular volumetric flask for preparation of standard solutions. So in volumetric analysis, solutions are needed to be accurately prepared to minimize the errors in results. So we have to be very accurately prepare the solutions. So other than volumetric flask, which are the other glasswares required? You want?
Prepared burette.
Just talking about preparation of solution now. No, don't go for standardization. Still we are in preparation of standard solution. So you need to prepare a primary standard solution and a secondary standard solution. So for that, what are the glasswares required? We have taken volumetric flask. See, today we are going to prepare 1000 ml 0.1 normal sodium hydroxide solution. Okay, this is a secondary standard, right? Sodium hydroxide is a secondary standard. You need to prepare 1000 ml of 0.1 normal sodium hydroxide solution. So what are the glasswares required? You tell me. So we need volumetric flask.
Dropper.
How much? 1000 ml capacity volumetric flask you need to take. Then what you need? Need weighing bottle. Sodium hydroxide is a solid, but we are not going to weigh using a butter paper because sodium hydroxide is hygroscopic. It will liquefy when it gets contact in the air. So we are using weighing bottle. Then what you need? Beaker. Then
Conical flask.
glass rod.
Dropper.
No dropper. Funnel. So you need volumetric flask 1000 ml, weighing bottle, beaker, glass rod, funnel. So these are the glass ones required to prepare sodium hydroxide. And chemicals required is just sodium hydroxide and distilled water. So in volumetric analysis or in analysis experiments, we use distilled water. So what is the difference between normal water and distilled water?
Normal water contains ions, whereas distilled water is completely pure and it does not contain any ions.
So when you are analyzing, these ions will interact with your chemicals or reagents and will give you some error in the reading. Hence, in analysis, we have to use only the distilled water. So now tell me for 0.1 normal sodium hydroxide, 1000 ml, how much sodium hydroxide you need to take? What is the quantity of sodium hydroxide you need to take?
Maybe 40 grams or 40.
40 grams in 1000 ml is 1 normal. You want 0.1 normal. So it will be
4 grams.
yes, 4 grams. 4 grams sodium hydroxide. You have to weigh using a weighing bottle. Then after weighing, so you can add some water to the weighing bottle and transfer to a beaker containing 50 to 100 ml of distilled water. So whatever the weighing bottle you have, sodium hydroxide, to that also you can add some water, rinse it and again pour back to the beaker. So using glass rod, stir well. After that, after dissolving sodium hydroxide in the beaker, using a funnel, transfer to 1000 ml volumetric flask. Again, you can rinse the beaker with distilled water. So after transferring to volumetric flask, you can see the marking. Have you seen volumetric flask?
No, ma'am.
You have not seen? Can you see here?
Yes, ma'am.
So
Yes,
this is
ma'am.
what standard flask or volumetric flask. You can see here, there is a marking here. Can you see the marking here?
Yes, ma'am.
Ma'am.
So you can see here, or in all the volumetric flasks, there is a line marking. Okay. See, these are the different sizes. See here, small one, 10 ml. This is 50 ml, 100 ml, 250 ml, 500 ml. So like that, we have different sizes. So which solution you want to prepare, you can use that volumetric flask. So how is the shape? It's little similar to conical flask. You can see here, right? Little, but it has a long neck. Before you start preparation of any solution, all the glassware should be washed properly. You need to check whether it is washed or not. Again, you need to wash it with water and rinse it with distilled water. First with tap water, followed by distilled water. So first you will weigh 4 grams of sodium hydroxide and dissolve in small quantity of water in a beaker. Using a glass rod, you need to stir, mix it so that sodium hydroxide solid will get dissolved in water. So transfer this beaker solution into volumetric flask using a funnel. Then rinse this beaker also. Then you need to make up the volume. So make up the volume means you need to add water till the marking. Just now what I showed that figure, in that you see the marking, right? Till that marking only you need to fill the water, not till the neck. Complete neck you should not fill. Only till the marking you need to fill the water. Then your standard solution is ready. And how will you see the marking? The liquids will have two meniscus. Yes or no? What are the two meniscus of a liquid? Upper meniscus and lower meniscus.
And lower.
So for colored we need to see, and for colorless we need to see the meniscus. So which meniscus will you see for colorless?
Lower meniscus.
Lower meniscus.
Colorless solutions you need to check the lower meniscus. For colored solutions we need to check the upper meniscus.
Upper meniscus.
So sodium hydroxide is a colorless substance. So when you prepare solution, it will be colorless. So you need to see the lower meniscus till the marking. That marking what you see on the neck, till that you need to fill the water. So then your solution will be ready. Similarly, you need to prepare a primary standard. So primary standard is oxalic acid. So what strength you are going to standardize? 0.1 normal. So same strength of oxalic acid should be prepared. 1000 ml, 0.1 normal oxalic acid. So how much will take for 1000 ml oxalic acid?
4 grams.
4 grams. Why 4 grams?
6.3.
Yes, it is 6.3 because 63 grams is 1000 ml is 1 normal. So we need to take
6.3 gram in a
0.3
oxalic acid.
oxalic acid in
Distilled water.
1000 ml. 4 grams of sodium hydroxide in 1000 ml, 6.3 gram oxalic acid in 1000 ml. So now you can use butter paper. Oxalic acid is a solid, so you can use butter paper to weigh the oxalic acid. First, you need to cut butter paper in a square. So properly take the measurement and cut the butter paper to a square shape and place this butter paper on a weighing balance. You have to tare, that is you have to make it to 0. So butter paper will have some milligrams of weight depending on your size of the butter paper. So make it to 0, then add the oxalic acid sample from bottle to the butter paper using a spatula. So you have to use spatula for solid transfer. So after weighing 6.3 grams, transfer it to beaker containing 50 to 100 ml of water, distilled water. So using a glass rod, mix well and after dissolving, if you get a clear solution, then transfer this beaker solution into volumetric flask, 1000 ml volumetric flask, and you have to rinse the beaker again with distilled water and transfer to the volumetric flask. Now make up the volume to 1000 ml using distilled water. So now your oxalic acid will be ready. So now oxalic acid is primary standard. Primary standards need not be standardized because they are highly pure substances. Whereas secondary standards are not pure substances, they need to be standardized. Hence, sodium hydroxide is standardized using oxalic acid. So till here, did you understand? All of you.
Yes, ma'am.
What is
Yes, ma'am.
standardization? What is primary standard? What is secondary standard? And how we are going to prepare standard solution. So next we'll see how to standardize the secondary standards in next class.
Okay, ma'am.
Okay, ma'am. Thank you.
So if you have any doubts, the next class you can ask.
Okay, ma'am.
Then we'll meet in the next class.
Thank you, ma'am.
Thank you. All of you. Bye.
Thank you, ma'am.
Thank you.